So, you're prepping for your GCSE computer science exam. And there are some questions that are almost guaranteed to show up. Well, the binary search is definitely one of them. It's one of those that trips people up, but today we're going to decode it step by step.
I bet you've seen this on past papers, and maybe it's even made you a little nervous. But look, by the end of this explainer, you'll know exactly how to walk into that exam and confidently nail all 3 marks. So let's get right into it.
Now, we're not just going to pull some random example out of thin air. No, we're tackling a real question, straight from an official OCR paper. This is the exact kind of problem you're going to be facing.
Okay, here it is, question 3C, part 1. Show how a binary search will be used to find the number 10 in the following dataset: 1, 2, 5, 6, 7, 10, 20. And there are 3 marks up for grabs here. So where on earth do we begin? Okay, so before we even touch the numbers, there is one golden rule you absolutely must know. Get this right, and honestly, you've often secured 1 mark before you've even started the search itself. The fancy word for this is a prerequisite, which, just means something has to be true before you can even start. So what's the one condition for any binary search? And here it is. For a binary search to actually work, the data must be sorted. It's not negotiable. If you look at our list, 1, 2, 5, 6, it's in ascending order. Perfect. If that list was all jumbled up, this whole method would just fall apart. So, rule number 1, the list has to be sorted. Right then, with that crucial rule locked in, let's get our hands dirty and actually do this search. We'll go step by step, nice and easy. First things first, you've got to find the middle value of the list. We've got 7 numbers here, right? So the one slap bang in the middle is the 4th item, which is the number 6. Simple enough? All right, now we get to the real logic of it. We ask ourselves a couple of simple questions. First off, is this middle number, 6, what we're looking for? Nope, we want 10. Okay, so next question. Is our target, 10, bigger or smaller than 6? Well, it's bigger. And that right there is the key. And this is where the magic of the binary search really happens. See, because our list is sorted and we know our number is bigger than 6, well, it can't possibly be on the left side, can it? So we can just chop off that entire first half, the 6 and everything before it. Just like that, we've made our problem way, way smaller. So now we're left with this much smaller list. 7, 10, 20. And what do? We just do the exact same thing again. Find the new middle. And what is it? It's 10. And boom, there it is. We found it. Search complete. See how fast that was? Just 2 little steps and we zeroed in on the number 10. But how does that turn into exam marks? Okay, this is the really important bit. Let's pull back the curtain and see how the steps we just did line up perfectly with the 3 marks the examiner is waiting to give you. We're going to look at the official mark scheme. So that first mark, you get it for doing that very first thing we did. The mark scheme says compare to / pick out middle value, which is 6. So by writing down that you found 6 as the first middle number, ding, that's 1 mark in the bag. Easy. Mark number 2 is all about explaining the why. You have to write down that you're getting rid of the left side because your target, 10, is greater than 6. That word because is everything. It proves you actually get how it works. You're not just guessing. And that third and final mark, you guessed it. It comes from doing the process again on that smaller list. The mark scheme wants to see you compare to, pick out, middle value, which is 10. By finding 10 as the new middle, that's it. You've just nailed all 3 marks. So there you have it. You've seen the question, we've walked through the process, and now you know the exact path to full marks. Let's just quickly boil this down into a simple blueprint you can use for any binary search question they throw at you. Honestly, just think of it like this. Find the middle, compare it, chuck out the half you don't need, and then just repeat. That is the entire game plan. If you can explain those steps on your exam paper, you're absolutely golden. So you've totally mastered how to do a binary search and get the marks. But here's something to chew on. Why is it so good? Why is this whole chop it in half thing so much faster than a linear search, where you just check every single number 1 by 1? Have a think about that, and you'll have an even deeper understanding of how these algorithms really work. Good luck with your revision.